Welcome. Hope you had a wonderful holiday. So we got term 2. It's a big term because normally you guys go on retreat at the tail end of term 2, but that's been pushed into term 3. So we've got quite a long term to work through vectors. If you have a look on sector, you'll see I think we finish about the end of week 6 or maybe week 7, which gives us sort of 3 weeks before exams. So we're not going to spend all that time on exam revision. I do have a bit of an idea about what I want to do for that time period. So we're starting vectors. We are going to be working from our blue book. So I understand some of you may not have brought that today. There will be an opportunity in a moment for you to go and grab it. And vectors is in chapter 3. So we're going to be working through chapter 3. There's a lot. It goes up to exercise 3L. Okay, so there's a lot of exercises there. It does start pretty easy, and I do think the maths involved in this is quite easy as well. Okay, so yeah, I think we'll find this pretty coasty. So this is going to be our notes book, all right, and then we're going to refer to the textbook for the questions. Now, if you've been doing physics, you would have, like what we're going to do today, you're going to be like, oh, cheese, okay, because it's a real overlap with what we've been doing in physics, or what you've been doing in physics. So first we have, if we open up to the first page, let's get started. This is for exercise 3A, and we're just starting to learn about the difference between vectors and scalars. Okay, so we've got a scalar is a quantity that has magnitude. Okay, so that word magnitude just means size, how big is it, all right? It doesn't care about direction. Whereas a vector is a magnitude, or it's a quantity with direction. It has a direction in which it is, in which whatever the vector is moving. And so we can represent quantity using a directed line segment. So that just means an arrow, all right? Where the length of the arrow represents the magnitude and the arrowhead shows direction. So here's a nice easy example. Use a scale where 1 centimetre equals 5 units to represent a vector of 30 metres per second east. So we're representing a velocity here. It has direction, 30 metres per second east. So what that means is we're going to want to draw a line, okay, where each centimetre represents 5 metres per second. And we need it to all be, it's going to be 30 metres per second. So how long are we going to draw the line?
6 centimetres.
6 centimetres is correct, Brad, thank you. So we need to draw a 6 centimetre line and it's pointing east. Okay? We have our first vector. Alright, here we have a vector of 25 newtons west. Okay, this arrow drawn here. Okay, and now it says underneath it, draw a vector of 75 newtons east. Alright, so if this vector is 25 newtons west, then 75 newtons is 3 times that, but in the opposite direction. So we need to measure how long is it, and then we're going to do 3 times it. So there's maybe 1, there's 2, and there's the third one. All right, and it's 75 newtons in the east direction. Okay, then we've got some stuff about vector notation. So if we have 2 points, A and B, all right, the vector from A to B, all right, so between A and B is written like this. All right, we put this like half a tick at the top. So that means we're going from A, or we begin at A, and we finish, we terminate at B. And we can also define vectors in terms of lowercase. So you could define this as vector A, you could define it as vector P, whatever. We can use pro-numerals to define vectors as well. Okay, vector equality. 2 vectors are equal if they have the same magnitude and direction. So if they're pointing in the same direction and they have the same size, then we can say that they're equal to one another. And then negative vectors are the same length but opposite directions. Okay, so up here's a good example. If this is vector AB, then so this is vector AB, then vector BA, okay, is going to have the same size, but it's going to be in the opposite direction. Okay, it's flowing opposite. And so if this is vector, if we define that as vector A, this is going to be minus A. All right, and then on the hexagon here, we've got some instructions. I might draw the hexagon up and we can follow along with what we have to do here as best as I can. Okay, and we've got A, B, C, D, F, O. And we've got these vectors drawn. We've got vector B and we've got vector A. Okay, draw vector OB. So that means we're going to start at O and end at B. That's going to be from here to here. Okay, so vector OB, we've drawn it there, and we can see it's actually the same direction as vector EO and the same size as well, because it being a hexagon, that's the middle of it. So we could also label that as A. It's got the same size and direction as vector EO. Draw a vector that begins at D and ends at B. That would be this one here. Draw a vector equal to AD. Okay, so starting at A and ending at D. And so we can just draw that there. That would be vector AD. Same size and same direction. Doesn't say it needs to be on the point. Determine a vector that is negative to B. Okay, so if this is vector B, well, negative to B could be OF. Okay, could be vector OF. It could even be vector CO, because that's going to have the same size and same direction as negative B. So OF or OC is equal to negative B. And that's all we're going to do today. So today's exercise 3A will be a bit of a cheese, and then it gives us some time to talk about our folio. So I'll just say with our folio, I've set the final date for it as next Friday, okay, which I think is ample amount of time. If it's going to be an issue, you can speak to me. But next Friday, yeah, hopefully we're working along well there. We will have some time today, maybe some time tomorrow. It's just whenever we sort of finish this work early, we'll have some leftover time to work on it. So let's get into 5A.